So this is for the signal transmission through the linear system. The communication system channel has a common feature of modifying or distorting the waveform of signal transmitted through them. The amount of distortion produced on the channel with given transfer function, so attenuation and phase shift at the function of frequency is rarely calculated using the Fourier transform techniques. So that therefore the Fourier transform techniques we write down the equation. The output signal will be this LF, H is the transfer function, BA is the channel. So this way is a channel. So the function, so that will be calculated by this equation. LF equal to HF multiplies the BF. So therefore the IT can be calculated. We use the inverse Fourier transform. So that will be calculation. The equation we substitute. Therefore we can calculate the signal transmission through the linear system. Could be your map as we need to option the cinema signal to connect the Yatania, Kupian who be on me. And I channel communication channel the mass signal, Pion like the commas with a signal, not the signal the house with Pong Pion Wale, Gomole, Pong Yatwala, Pity. By John Lesser, a distortion people or Dion Pity. Yamlo Eddie distortion people are less way. I channel the transfer function was heated. I transfer function the wing out channel and whom you like, 12 channel yam. The Yamlo transfer function HF wing out BSW, 12 signal FY yama pity. AF gas wing, AF who died to me will be like the commas, the integration in Yellow Yame. How this way, signal transmission through the linear system of Yatara pity. So therefore the information about the signals can be calculated. Information content of the signal. Those are supported as information. And so then we find out the information content. This information content of the signal can be calculated by this equation. So the information is conveyed by the signal that change the unpredictable fashion. It's important to have some method of evaluating the information content of signal. Because this will determine whether or not the signal can be transmitted over a particular channel. This is the important aspect. So that before you are sending a signal, we also have to evaluate the information content on the signal. If this content, depending on the content, some of the information can pass through the channel, some cannot pass through the channel. And therefore, we have to evaluate the information content of the signal is important. Only that you know it can you can make sure that the signal can be transmitted over a particular channel. So that the content of the signal is a measure in bits. So there will be all the content you have to measure in bits and the number of binary digits required to transmit it. The information capacity of communication channel is limited by bandwidth. So therefore, the which determine the maximum signal speed and by noise which determine the number of distinguishable signal level. So therefore, the important one is that information content is determined by the bit. In the meantime, bandwidth. Bandwidth is the number of information capacity. It determines the information capacity. The signal the channel shut down my way. I signal about it, power in the area, easy that chili. A power move, a yard will move your money. The channel gas channel shut down and chili. A channel capacity or information digit the big binary digit that time out today. Now we block channel a time the information capacity go down, bandwidth at time out today. A bandwidth the information about it, digit the binary digit the bit as we the information who signal who are somebody channel who channel mechanic, Santa Board easy at church. Then also we learning about the information transmission. Information transmission. So the information capacity of communication channel is specified by the Hartley law. This equation does not say how to evaluate the number of detectable level. And therefore we can calculate for the S and mutually perpendicular acids is a D, and also the number of interchange is a M, Q is a point of the hyperspace. So we write down the equation, that equation we can write down. So number of messages can be transmitted and the noise power obtained at the Shannon equation. So n-dimensional speed. So that will be the Z equation if we can calculate the number of messages can be transmitted and the noise power. So In this case, Hn is a perpendicular distance from the point to the end exit. So that way, therefore, Hn is a perpendicular distance from the end exit. And all the initiality to beyond like the comma, so you know, Eddie, below, such way channel the initial swine up on a blouse sheet as well, hardly low on it, Lamata Chitty. And Eddie must be the signality a go low mass with that signality as we have done Yamu or not get people on a chitty. And the Yamu Eddie, not the low channel Huma. Shut down what is information must be blocked. Wisely, no, Sunyamuri power in this row, Shen when Nia, Quetchet Achite. Elo Quetchet Kamasui, no, Eddie Masui, the suitable ACDA and SHime, suitable anti-mission she, a time like he is space she may, Eddie Marchi, a Guawidia, so not defeated, so not to Nimia, to Nimia in a popular yard. Now, HAR, so Eddie, no, and SATU, not Tauman Jani, a Guawi, a time from Chitty. Tabalasui. The information transmission method the HLF setting. So the double-sided amplitude modulation. So for the double-sided amplitude modulation, we write down this equation, modular carrier. So a modular carrier set equation here. So this is a function itself of this function, A to B plus BVM is not T is a function, and therefore we can calculate the modulated carrier, this equation for the modulated carrier. And in the meantime, M that of the modulation can be calculated. Modulating signal amplitude divided by unmodulated carrier amplitude. So that this is the A divided by K. So therefore this equation can be expanded to the one. Now, in this case, we can utilize FC as a carrier frequency, upper high band and a lower high side band frequency SC minus F and SC plus F. So those we substitute here, we calculate this equation. The modulated carrier becomes the equation. This is the modulated carrier equation. So when you draw this diagram, then we say this is the carrier frequency and this is for the carrier envelope. Alors, to who said your mother, the best side band amplitude modulation young today. Alors, frequency are so carrier we want like the comma amplitude modulateဖြစ်တယ်လို့ခေါ်တယ်။ဒါ waveform ရဲ့ညီမျှခြင်းကတော့ဒီညီမျှခြင်းရှိပဲ။ A ညီမျှ K plus VMT ဆိုတဲ့ညီမျှခြင်းရှိမယ်။အဲ့မှာ modulate မလုပ်ရသေးတဲ့ carrier amplitude က K ဖြစ်ပြီးတော့เนาะ this EMD ဆိုရင် modulating signal ဖြစ်တယ်။ VMT equal to A cos เนาะ 2 by FNT ဆိုရင် modulating signal ဖြစ်တယ်။ဒါဆိုရင်တို့ညီမျှခြင်းဘယ်လိုရေးလို့ရလဲဒီညီမျှရင်ရေးလို့ရတယ်။နောက်ပြီးတော့ဒါကိုဆက်ပြီးရေးလို့ရတယ်။အဲ့တော့အဲ့ဒီ modulation ကအတိုင်းအတာဘယ်လောက်ရှိလဲဆိုတော့ N ဆိုရင် modulating လုပ်တဲ့ signal amplitude နဲ့modulate မလုပ်ရသေးတဲ့ carrier ရဲ့ amplitude အဲ့နှစ်ခုအချိုးဒါဆို A ကို K နဲ့စားလာနဲ့ညီးတယ်အဲဒါညီမချင်းကိုထည့်လိုက်တဲ့အခါမှာဆိုဒီအောင်ရလာတာဖြစ်တယ်အဲပြီးတော့မှအဲ့ဒီမှာဆိုရင် lower နဲ့ S carrier frequency က SC ဖြစ်ပြီးတော့ lower နဲ့ upper side band frequency ကတော့ FC minus FM နဲ့ FC plus FM ဖြစ်တယ်ဆိုရင်ဒါလိုညီမချင်းထည့်လိုက်ရင်ဒီအောင်ရမယ်ပြီးတော့မှ modulated carrier ဆိုရင်ဒီညီမချင်းကိုရရှိမှာဖြစ်တယ်အဲ့တော့ဒီမှာကြည့်လိုက်တဲ့အခါမှာဆိုရင်ဒါဆိုရင် carrier frequency အဲဒါ modulate လုပ်တဲ့အခါမှာ carrier amplitudeဒီပုံနဲ့ရရှိမှာဖြစ်တယ်ဒါပါလို့ဆိုရင် double side band amplitude modulation ဖြစ်တယ် so this is for the double side band amplitude modulator the modulator is multiplying the together carrier and modulating signal so this is the double side band amplitude modulator so the modulation achieved by using a network and non-linear characteristic So therefore, the power series equation calculated, the output characteristic is this power series equation. The equation you get, so finally you got the output equation like this. So this is for the output equation. Now modulating look the comma so this signal go ma, carrier signal and modulate look the signal and who like the comma so the side band amplitude modulation or yashima chite. Now Eddie Masoin on Eddie Twalare to modulate the signal output the power series, you imagine a popular yare. နောက်ပြီးဒါကိုဒီ A တန်ဖိုးတွေ B တန်ဖိုးတွေထည့်လိုက်ရင်ဒီကောင်ရလာမယ်အောက်ဘုတ်ကတော့ဒီညီမရင်းနဲ့ရရှိမှာဖြစ်တယ်နောက်ဆုံးအောက်ဘုတ်ဒီညီမရင်းရမယ်ဒါကဘာလဲဆိုရင်ဒီ modulated လုပ်တဲ့ double side band frequency ရဲ့သင်္ချာညီမချင်းဖြစ်တယ် So this is the amplitude spectrum of the data signal when you are sending the data signal those are the amplitude spectrum of the data signal Those signal equation we can write down this equation like this. so that amplitude စာ8 kHz စာဆိုတဲ့ဒါပါဆိုရင် data signal တွေရဲ့ amplitude spectrum ဖြစ်တယ်အဲ့လို spectrum ဖြစ်တယ်ဆိုရင်သူ့ရဲ့ညီမျှချင်းကဒါနဲ့ဖော်ပြလို့ရတယ် so we talking about the amplitude shift keying so this is a use to transmit the data signal amplitude shift keying method is utilized to transmit the data signal they mostly used for the telephone line and so the FN also got the sound of 2 ASA signal because frequency modulated signal is a content of the amplitudes are 2 amplitude shift keying signals အဲ့တော့အဲ့ဒီမှာဆိုရင် amplitude modulation ပြုလုပ်တဲ့အခါမှာဆိုတော့ data signal တွေကိုเนาะတည်ယူပို့ဆောင်ဖို့က amplitude shift keying စနစ်ကိုအသုံးပြုတာဖြစ်တယ်အဲ့တော့အဲ့ဒီမှာဆိုရင်တော့ ASK อ่ะဆိုရင်เนาะဟိုမှာ frequency modulation อ่ะဆိုရင် ASK signal ကိုပေါင်းထားတာနဲ့ညီတယ် so then will be that this one is here this is the data signal and this is the audio frequency by adding this one you got this one is the amplitude ASK amplitude spectrum you can get it so the ASK signal generated by multiplying the data signal by audio tone so this one the average sheet the data spectrum to center frequency equal to the audio tone so this is center frequency equal to the audio tone so that will be the data bandwidth this one this is data bandwidth this is the ASK bandwidth therefore we write down the equation this equation ASK equal to DSBAM so carrier plus upper and lower side balance အဲ့တော့ဒီမှာဆိုရင်ဒါပါလဲဆိုရင် data signal ရှိတဲ့ဒါ data signal သူ့မှာ audio frequency နဲ့ပေါင်းလိုက်ဆိုရင်ဒါနဲ့ရသွားမှာဖြစ်တယ်အဲဒီကောင်ကဆိုရင်ဒါ center frequency လို့ခေါ်တယ်ဒါဆို data bandwidth စာတရားနဲ့တူရှိတယ်အဲဒါဆို ASK bandwidth ရှိတယ်တော့အဲ့ဒီ ASK bandwidth ဆိုရင် data signal ဥမာ audio signal နဲ့မြှောက်လိုက်တယ်ဆိုရင်ဒီလို amplitude shift keying ဆိုရမယ်ဒီ data signal ကို audio တုံးနဲ့မြှောက်လိုက်တယ်ဆိုရင်ဒီလို amplitude shift keying နဲ့ရမှာဖြစ်တယ်အဲမြှောက်တဲ့အဲ့ဒါကြောင့်မလို့တို့ညီမျှချင်းကိုတို့ဘယ်လိုရေးလို့ရလဲဆိုရင် ASK က DSBAN ရဲ့အဲ့ဒါဘာနဲ့ညီလို့ carrier ရဲ့ upper နဲ့ lower side band တွေပေါင်းတာနဲ့ညီတယ်ဒီ signal ရဆိုရင် carrier နဲ့ upper lower side band တွေပေါင်းတာနဲ့ညီတယ် In the meantime so we can talking about the frequencies and phase shift keying FSK method the binary equilibrium of FM binary 0 transmitted as an audio frequency 0 so the FSM is a more convenient to consider the 2 ASK waveform with different carrier frequency so frequency phase shift keying is a 2 ASK waveform summing with different carrier frequency and therefore the carrier frequency FC is a this area equation carrier deviation is this equation modulation in the beta is this one and therefore this will be that we calculated for the BFSK is a 2B multiply 1 plus beta. So that will be the decrease signal we combine this and this one combine you call the FSK signal. So that this FSK bandwidth you can get like this. This is the FSK amplitude spectrum. Alors FSK ကတော့ frequency shift keying ဆိုတဲ့အဓိပ္ပာယ်တော့ဘာလဲဆိုရင်အဲ့ FN ကเนาะ ASK နှစ်ခု waveform နှစ်ခုပေါင်းတာနဲ့ညီတယ်เนาะ FSK က sound of 2 ASK waveform with different carrier frequency amplitude shift keying waveform နှစ်ခုနဲ့เนาะကွဲပြားခြားနားတဲ့ carrier frequency တွေနဲ့ပေါင်းခြင်းဖြင့် frequency shift keying ကိုရရှိမှာဖြစ်တယ်အဲဒါကြောင့်မလို့အဲ့ဒီမှာဆို carrier frequency ရဲ့ညီမျှခြင်း FC ရဲ့ညီမျှခြင်း F4 plus F1 minus F0/2 ရှိတဲ့ carrier deviation delta F ကတော့ F1 minus F0/2 ဖြစ်တယ်ဆိုရင် modulation beta index beta ကျတော့ beta က delta F ကို beta နဲ့စားမယ်အဲ့တော့ BSK က 2B multiply 1 plus beta ကိုရရှိမှာဖြစ်တယ်အဲဒါကြောင့်မလို့ဒါဆိုရင် bandwidth ကိုဒါတွက်တဲ့နေရာချင်းဖြစ်တယ် BFSK ကဆိုရင် frequency shift keying နဲ့ bandwidth ဖြစ်တယ်အဲ့တော့ဒီမှာဆိုရင်ဒီ amplitude signal နဲ့ဟိုပေါင်းလိုက်ဆိုရင် FSK signal ရမယ်အဲ့ဒါတွက်ဒါဆိုရင် data bandwidth ကိုတွက်ရှိမှာဖြစ်တယ်ဒါ amplitude FSK amplitude ရဲ့ spectrum ပုံဖြစ်တယ်Then we're talking about this sampling.